Geometry, how are you guys? Hopefully everything's going well. We are in 5.5, which is the last section of chapter 5 that we're going to do. There's a couple things that we're going to be doing in this section. First off, one of the things we're going to talk about is triangular inequality. And basically what we're going to do is learn how to prove that a triangle is a triangle and how to identify that. Second thing we're going to do is we're going to talk about a Hinge Theorem, and then we're going to work on some of those problems. And so you'll have a chance to understand how that works. Okay, but review, as we kind of begin, think about the review, what we've talked about in the past. We've talked about in a triangle that the side opposite, so for instance, if the side is the biggest side in that triangle, what do we know about the angle that's opposite it? The angle opposite of that is going to be the largest. So what we're going to talk about here is kind of similar, but it's also different. What we're going to talk about is if we have a triangle. So if I have a triangle, and that triangle is a 10, 9, and 8. So we have a triangle that's 8, 9, 10 is our sides, right? How do we know that that triangle actually works? Well, here's how you will learn, okay, what you'll do. First off, you always want to add the two smallest sides. So the two smallest sides are, in this triangle, are 8 and 9. So if you add the two smallest sides, and they are bigger than the third side, then, which they are in this case, we would know that this is a legit triangle, a triangle that actually works. So, what you're simply going to do is add the two smallest. So you're finding the two smallest, add them together. Why? Because if I add the 9 to the 10, that's bigger in itself of that other side. So you have to add the two smaller sides. So when when it's greater than, it is a triangle. Greater than. I'm going to show you something. So, here's my supposed triangle. What are the two smallest sides? 5 and 2. Are they greater than 8 is the question. 7 greater than 8. Is that a true statement? Is this true? No, it's not true. Notice that 5, if I were to put it together, it would make a gap. You see that? There's a gap here. 5 would come to here, and it's just going to be just short. So what you're going to realize is that if it's less than, it's going to not work. It's not going to form a triangle. It's not going to form anything. Okay? So keep that in mind. So adding the two smallest, the biggest, if it's bigger, it's going to be a triangle. Adding the two smallest gives it, if they're bigger than that third side, it is going to be a triangle. If it's smaller, it is not going to be a triangle and it's not going to work. Now let's think about this for a second. In any inequality, you have greater than, less than, or equal to. Think about this. What happens if my two sides, 5 plus 5, which equals 10, so therefore 10 is equal to 10. What do you have? Think about that for a second. What would it form? If they're equal, if those three sides are equal, that you don't have a triangle, what you have is a straight line. You have a collinear shape. So, keep that in mind as you do these problems. So what you're going to do in this lesson, the first part of this lesson, there's two parts. The first part is, hey, are there triangles? How do we know if they're a triangle? Well, how do you know they're a triangle? You add the two smallest sides. So adding those two small sides gives you an answer, and that determines whether or not it's going to be bigger or smaller than that third side, and therefore you know it will be a triangle. So here's the question they ask. A designer is trying to optimize a kitchen, and they want to optimize this kitchen so that they have the distance between the stove, the refrigerator, and the sink to be that cannot exceed 20 feet in total. So when this person's decorating this kitchen, they want this triangle to be no bigger than 20 in the middle. Now, think about this for a second. The stove to the refrigerator is 5. The refrigerator to the sink is 7. And the stove to the sink is 6. So, let's ask that question. Is this a triangle? 5, 7, 6. Is that a triangle? 5, what are the two? First off, what are the two smallest numbers? The two smallest numbers are 5 and 6. 5 plus 6 is 11. Is 11 bigger than 7? Yes. Is the total of that under 20? Sure. And therefore, that would actually work. That will actually work. Think about the next one. They say, what if I put the sink 4 feet, this 6 feet, and this one 10 feet? Oh, it's under, is it equal to 20? Sure is. Question, is this a triangle? Well, the two smallest sides are 6 and 4, which when you add 6 plus 4, you get 10. 10 equals to 10. Therefore, is this a triangle? No, it's not a triangle. So it won't work. So what you're going to do, remember, when you're identifying whether it is a triangle inequality, whether it's a triangle or not, what you will have to do is always pick the two smallest sides, add them together, and if they add together and they're equal, it is not a triangle. If it's less than, it's not a triangle. If those two added together equal a greater number than the third side, then you will have a triangle. Now, the second thing we're going to learn today is the Hinge Theorem. The Hinge Theorem. Now, the Hinge Theorem is kind of a different theorem, and it's illustrated by what you do with a door. Think about the hinge in the door. A door has hinges. All doors have hinges. And so what happens with that hinge that you have? As you open the door to make more room for somebody to come in, what happens to the hinge angle? That little hinge, like so, each door has a little thing like this, has little screws in it. So if you want to go check out your door, and it has a little circular thing there, and that hinge opens and closes, opens and closes. So as you open that door wider, what's the angle from that ball? Is it going to be bigger or smaller? If you go check your door, you will find out that your hinge, as you open that door wider, so that distance across from it, that side across from it is bigger, you will notice that your angle is bigger. So what we can talk about on this hinge theorem, what you will see is that as the hinge opens, the side is bigger. The hinge gets smaller, the sides get smaller. So think this through. If you're memorizing this theorem, the hinge theorem, what you will say is as the bigger the side, the bigger the angle. The smaller the side, the smaller the angle. Well, all you're learning in this section is if that hinge is getting smaller or bigger, you will have a bigger or smaller side across from it. All right? That's the key to this whole concept. So, let's do an illustration. Got this. Boom, 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 boom. Flip. 53, 37. So, class, 37 degrees, 50 degrees. So now watch carefully. Notice that these two sides are equal. So these are hinges. Let's pretend that this is our hinge. So this angle's 37, this angle's 53. Can somebody tell me which one of these two sides, UV or VW, which one will be bigger? Remember, bigger the angle, bigger the side. So UV is going to be smaller than VW. Does everybody understand that? Now let's think this through. Do the reverse of that. So what if I asked you, this is for and this is 8. And I asked you, hey, if these are the numbers of sides, what would be this angle? Was this angle going to be bigger or smaller than this angle? Okay, will angle 1 be smaller than angle 2? Erase that. Will angle 1 be smaller than angle 2? And you're going to say 1 will be smaller. Why? Because the smaller side has the smaller angle. The bigger side has the bigger angle. So when you're comparing these, that's how you're going to know if it's bigger or smaller. Bigger or smaller. Does anybody have any questions on the Hinge theorem? The Hinge theorem, basically, the bigger the side, bigger the angle. Triangle inequality. Hey, if it adds up, it has to be bigger, otherwise it will not be a triangle. Those are the two concepts you'll learn today in this lesson. That's all you need to know for this lesson.